Good morning, everybody. We're really in the home stretch now. This is class 24. We only get up to 30 in the semester, so good job for hanging in there. You know, our ranks have thinned a little bit. I think there's maybe just over half of the class here right now. There's definitely a relationship between how often you put yourself in class and how well you ultimately do in the course. It's tough to learn this stuff even when you're reading the book and coming to class and doing the assignments. I mean, it's hard to learn to begin with, but then when you cripple yourself by missing a lot of classes or not reading the textbook, you know, when you put yourself at that kind of disadvantage, it really is hard to do well. So I'm glad that you're here this morning. The next homework assignment, number 14, which has to do with inflation, that's the subject of today's discussion. That's due a week from today, Thursday the 15th, and that'll be our final class period before Thanksgiving break, right? It's just in the nick of time that we're having that. So any questions about the announcements? All right, so today we're talking about inflation, and just to set the stage, I wanted to show you some car prices from a long time ago. Back in the 1950s, you could get a new car for $1,395. You could probably find a car nowadays that costs that much, but it definitely wouldn't be a new car, and it wouldn't be one that was hand-built. And that's something to think about, is that back then they didn't have automation in the same way that we do now. So the price of that car represented not only a lot of material costs, but really an extremely high amount of labor costs as well. So, you know, I'm sure you've heard these sorts of things from your parents before, you know, how much a candy bar cost when they were young, how inexpensive a gallon of gas was. And just to show my age, I remember when a gallon of gas was 69 cents. It's definitely not 69 cents now, but when I was really young, that's how much it cost. So we know that inflation is the increase in prices because the supply of money is increasing. And so then what that does is it reduces the value of money over time. So remember, we've talked about how future dollars are discounted. And we use the phrase, or the word discounted, to kind of draw the picture that the amount of the money is getting smaller when you move it backward in time to account for this inflation effect. Now, if you look at a graph of inflation over time, you can see that in our more faraway history that there were these extremely high swings of inflation. And, you know, back in the 1700s and even the 1800s, inflation from year to year, you know, one year prices would increase by maybe 30%, and then the next year prices would decrease by maybe up to 20%. But in recent years, we've kind of become accustomed to positive inflation, and the range of fluctuations have decreased quite a bit. Here's a closer look at wage growth, and what wage growth is one of the key factors that drives inflation. If you look at, you know, why are prices going up over time, it's partly because there's more money in circulation. And so for there to be more money in circulation, one of the ways to get that money in circulation is to be paying workers more. And so you can see that the average wage growth has varied from about 1.5% up to just slightly more than 4% in the last few decades. But there's never been a time on this graph where the wage growth was negative, meaning that in a following year, people are actually on average earning less than they did the year before that. So of course there's other ways that money enters the economy. There's interest payments to those who are investing, but wage growth is one of the reasons why, in general, inflation has been positive. Now think about what it would have been like to live in these years, where you didn't know if the prices were going to go skyrocketing high the next year, or maybe the prices would actually plummet in the following year. And that uncertainty is kind of bad for an economy, and it's really hard for individuals as well. It's hard to know if you're a farmer, what your goods may be worth when your crops finally mature and you're able to sell it on the market. And so you can't make investments in, should I buy a new plow? Should I buy more land? if you're not having a more solid idea of what the value of the crops are. So this really rapid-fire change of inflation is something that the Federal Reserve has been charged with trying to control. I'm sure many of you have heard about the Federal Reserve Bank, but their two main objectives are to hold inflation within a narrow band of what's considered acceptable, and then also to support full employment in the U.S. economy, so trying to minimize the unemployment rate. So let's talk about some of the technical terms that we're going to be using today and throughout this chapter. First of all, we've already discussed inflation. It's the increase in the amount of money needed to obtain the same goods or services. So prices are going up because of inflation. And so what's inflating is prices. Sometimes people make the mistake of thinking that what's inflating is the value of a dollar, and actually the value of a dollar is decreasing because of inflation. Now we can measure the amount of inflation on the basis of a rate where we're taking the time into account when we have the inflation amount as a percentage change of the base. And so we can represent it as a percentage in the same way that there's interest and interest rate. So interest is the dollar amount, rate is when we express it as a percentage. We do the same thing with inflation, and we're going to assign it the variable f. And that's really important because today we're going to be looking at a couple of different percentages, and f is the percentage that's talking about the rate of change of the currency's value. So think of it this way. If your bank was only paying you the same interest rate as the rate of inflation, then that means that you're not getting any gain in purchasing power. So think of it as what if next year a loaf of bread was going to cost $1.10, and today you invested $1 into an account that paid 10% interest. So you'd have $1.10 at the end of that year. The bread costs $1.10, so you can buy the same amount of bread now and in the future if the interest rate you're earning is the same as the inflation rate. And so purchasing power, you can think of purchasing power as just how much stuff you can buy with a certain amount of money. Now, the real interest rate is the interest rate that you're earning once you take out the effect of inflation. So you can think of the real interest rate as whether you're gaining purchasing power. So are you earning interest that not only covers the increasing costs, but are you also earning enough interest that you're covering the increasing costs, but then you're also going to have the ability to buy more stuff in the future than you bought now? Because if not, then there's no point in investing. I mean, there's no sense of putting the money away for later if in the future you're going to be able to buy less than you can buy now. So what we're hoping for whenever we invest is not only to cover inflation, but then also to have an increase in purchasing power. So in just a moment, I'll show you an equation that that takes into account the real interest rate and the inflation rate. I is not what banks usually quote. When they tell you what interest they're paying you, they're just telling you, this is how much you're going to get. It doesn't take the effect of inflation into account. So what banks quote you is I sub f, what we call the inflation-adjusted interest rate, or the market interest rate. Now, this name here, inflation-adjusted interest rate, that's the thing that our book calls it, but I think that that's maybe not the clearest way for most people to understand it. I think that market interest rate is easier to remember and connect with because I sub f is actually what you get paid. So I sub f, if you're thinking of it as a goal, like how much you want to earn, then you'd want to earn enough to cover the inflation and also have some increase in purchasing power I. And so the formula for I sub f takes into account both inflation and interest amount. And so here at the bottom of the screen, the market interest rate, I sub f, is the real interest rate plus inflation plus the interest rate, the real interest rate times inflation. So that shows why you add the two together and multiply them. It's because if you're going to account for the inflation and the interest, then there's compounding there. And so you can see in the expression here, if we want to find some present value of a future amount, so the amount that you're going to have in the future has to be discounted according to the effects of inflation and the real interest rate that you hope to earn. We're going to use this formula a couple of different ways today. But the critical thing is you need to memorize those three definitions. The only way that you're going to be able to understand and interpret both the homework problems and upcoming quizzes and the final exam, the only way that you're going to be successful at that is if you are able to know, when you read a problem statement, be able to identify, all right, this is the inflation, so that's F. They're talking about some bank and what they're offering. That means that's a market interest rate, so that's I sub F. And so you need to become kind of adept at interpreting those word problems to know what percentage goes with which label. And I'll try and give you some practice at that today. Before we get into the in-class exercise, though, let's just do a quick illustration. Maybe you've been to a grocery store before where they have like a basket of food as an illustration of, if you buy the food here, it's cheaper than if you buy it at our competitors. I mean, I've seen things like that before when I went into grocery stores, where they'll have like things that they think people are typically going to buy in a week. And so it's called a basket. And in fact, the government does the same thing. It's not just grocery stores. Sometimes there will be a representative list of things that the government collects prices on, and then they use that list of goods to understand how prices across the country and over time have been varying. But let's just say, for instance, that you want to buy this stuff. So if you bought this stuff now, it's $25. And what we're projecting is that F is 3%. Do you remember what F is? That's the inflation rate. So what we're saying is every year, prices are going up 3%. So today it's 25. So next year, this basket of goods would cost 25 plus 3% of 25. And then the effects of that compound, because in the second year, it's going to be 3% more, 3% on top of the year one price. And so the effects compound. So let's look at what is the price going to be in 15 years. So that's the first thing we'll do. Now, we can use the same formulas that we've used through the rest of the semester. So for instance, you may remember the equation F equals P times 1 plus I to the n. So what we're saying is the future amount is the present amount plus some increase. Now, I is just some rate of interest. And we can substitute the letter F in the same place that we used to have I, because F is a percentage. And here we're saying that the price is increasing 3% per year. So we want to know what's the future price. So our current cost of this basket of goods is $25. And we're saying 1.03 to the power of 15. So that is $25 times 1.55796. So that means that in 15 years, the price will be $38.95. Price in 15 years. Okay, so any questions with that so far? Okay, now the second part of this example is, so let's say that you want to be able to buy it in the future. So you're going to save $25 today, so that's how much you'd have to buy you'd have to spend to buy the basket of goods. So you put that into an account, and what we want to find out is how many baskets of food you can purchase in 15 years if the rate you're actually going to earn from the bank is 7%. So that's talking about the I sub f. That's the market interest rate. So how many baskets of food if we know the price per basket is $38.95? Okay, so we can use the same equation as we did above. The future amount is the present amount, 1 plus I to the n power. Now the I that we're talking about is I sub f, because that's the amount that the bank actually pays. So how many dollars will we have in the future? We put in 25, and it's going to be 1.07 to the 15th power. And if we do that, it's 25 times 2.7590. So in the account at the end of the 15 years, there's going to be $68.98. So the last thing, all we have to do is just find the ratio. So we've got $68.98, and the price per basket is $38.95. So how many baskets can we buy? Well, that's 68.98 divided by 38.95, and that means we're going to be able to buy 1.771 baskets. Okay, so let me ask you some questions. Why is the price of a basket of food higher in the future? Why doesn't it still cost 25? Because of inflation. And why are prices inflating? Because the value of money is decreasing. And why is the value of money decreasing? Because there's more money in circulation. Good. All right. So why is it that this person can buy, if they only invested $25, why is it that they can buy more baskets in the future than they were able to buy today? Because today, if they made the purchase now with that $25, they could only get one basket of food. So why is it that they can purchase 1.77 baskets of food in the future? Exactly right. So he said the interest rate the bank pays is higher than the inflation rate. So in this case, the value of the person's money in the account was growing faster than inflation was eroding the value of the money. So over time, inflation is kind of is robbing you, because the money that you've got is worth less in the future. And so through investing in an account where I sub f, if I sub f is greater than f, then you'll have more purchasing power in the future. So let me write that on the board. If I sub f is greater than f, then purchasing power increases over time. So you can buy more things in the future if the interest that you're earning is greater than inflation. And so what's the opposite of that? The opposite is if your market interest rate that you're earning is less than inflation, then your purchasing power is decreasing. And that's what happens to almost everyone these days. The money that you have in your checking account, for example. If your checking account pays any interest, it's a very, very low rate. I mean, it would be an extraordinary thing to find someone whose checking account is paying even 1%. But the inflation rate, it's usually between 2 and 3% in recent years. And so what that means is that your purchasing power, the purchasing power of the dollars in your checking account decreases over time. So you shouldn't put too much in your checking account, because however much is in there, you're losing money compared to a different account that maybe the market interest rate would be greater than inflation. Okay, does anybody have any uncertainties that they need to clarify? Any questions? All right. So let's look at the scenario we're going to analyze here on the in-class exercise. A certain item costs $5,000 now, so that's the P, that's the present value. It's expected to experience 4% per year price inflation during the next several years. All right, so this 4%, is that I sub F, or F? Remember, I is the real interest rate, I sub F is the market interest rate, and F is the inflation rate. So this 4%, what variable is that? It's F. It's the inflation rate. All right. So what is the expected cost in 5 years? We can use this formula. F equals P times 1 plus F to the n power. Okay? Part B, if your investments must produce a real interest rate of 10%, so which variable is that? Real interest rate, remember, is I. So I is going to be 0.1. Okay, so if your investments must produce a real interest rate of 10%, what's the inflation-adjusted interest rate they should earn to achieve this? Now remember the formula that relates inflation-adjusted interest rate, real interest rate, and market interest rate is this. I sub F is equal to I plus F plus I times F. So part B is saying you want to earn a real interest rate of 10%. So that's saying you want your I to be 10%. And we've already learned what F is. So now they're asking what is the inflation-adjusted interest rate that they should earn to achieve this. Okay, and then finally, how much should be invested today to purchase the item in 5 years? Okay, so I'm going to give you some time to think over this, and I'll hand you the paper. We'll go through the calculations, and I'll be circulating around as you're working on it. All right, so I suggested that it's a good thing to write down the variable designations in the problem statement. And so F, which is the inflation rate, is 4%. I, real interest rate, is 10%. And you can see that in part B, it's an unknown what is the inflation-adjusted interest rate. And in other words, remember that the other way of describing I sub F is the market interest rate. So in part B, they're asking, you need to go and find a bank. What interest rate are you looking for that bank to pay if you want to do a certain thing? All right, so in part A, you can see that if it's $5,000 now, then in the future, after 5 years, then it's going to be $6,083. That part's fairly straightforward. But then in part B, it's saying if you want to have an increase in your purchasing power and cover the effects of inflation, then how much does the market interest rate from your bank, how much should you be earning from your bank? And so what we're saying is if the bank pays 14.4%, then that means you're covering inflation and you're having an increase in purchasing power of 10% per year. So each year you're able to buy 10% more than the year before because the amount of money you have is growing faster than the prices were increasing. Okay, so that 14.4% represents that. And now the part C is maybe the trickiest. And the way to think of it is, if you want to be able to buy this by investing in the account that pays this, how much should you put in? So this is going to be the interest rate. This is going to be the future value. And what we're solving for is the present amount that needs to be deposited. And so we just use the same structure of the equation. F equals P times 1 plus an interest rate to the n power. So instead of solving for F, this time we're solving for P, the amount that we should deposit into the account. And you can see that when we do that, it turns out to be $3,104.60. All right, so any questions about that one? All right. Now in part 2, we're going to take another look at price increases. This is a plane that's an Airbus 380. And with any luck, I'll get to fly on one of these planes this summer. I haven't been on one before, but it seems pretty crazy. It's a double-decker airplane. It's just enormous. The price is $340 million. And if we expect that the price is inflating 9% per year, then how long until the cost is $500 million? Now, on the handout I've given you, part 2, where it's unknown time, I give you a hint that you can use the log function on your calculator to solve for that. Because when you are going to be solving for an unknown, the unknown is the exponent. Like, what's the formula that we're using for this one? Well, this is a problem of the type f equals p 1 plus f to the n power. This is the general form of future and present for an interest rate to some power. Well, n is the unknown. And if you think back to like algebra, the way that you can get the n down out of the exponent is by using the log function. So I'll give you a moment to think about that. Again, you know, it's a good thing to just identify all of the unknowns, all of the givens. But what we're solving for here is n, the number of periods until the cost, the future value, f, is 500 million. Okay, so the way that these logarithms work is that if we rearrange, what we're trying to do is solve for n. So we need to isolate that variable. And if it's up in the exponent, the way to do it is by taking the log of both sides. So you can see on the left side, it's the log of f to p. And on the right side, if I take the log of all of this, then ultimately what I can do is bring the n in front of it. And so it's the log of what's on the inside of those parentheses times the n. And then algebraically, I can solve for n by just dividing the left side of the equation by log of 1 plus f. So after I do that and make the substitution of what is p, what is f, then it will be 4.475 years. And the way to double check that then would be just to back substitute into the equation, where we know p is 340 million, and so we do 340 times 1 plus f, where f is 0.09 to the power of 4.475. So it'll take 4.475 years. Any questions about this one? Let me give you a minute to finish copying. One of the kind of interesting things that we can talk about is the idea of deflation. And you saw earlier in the class that back in the 17 and 1800s, there were quite a number of years where prices actually decreased over time. So what that means is that, you know, maybe if a bushel of corn costs $1 today, then next year the bushel of corn maybe costs 90 cents. And think about what sort of incentives would arise in a society like that if you knew that the price of something was actually going to be cheaper in the future. And one way to understand it is oftentimes we can think of the computer that you're able to buy in 6 months is going to be more powerful, and maybe the thing that you want to purchase, whether it's a video card or a certain hard drive, it's probable that that item, the same thing, is going to cost less in the future instead of more. And computers are the kind of rare exception of the list of things that usually prices are increasing over time, but computer parts deflate in prices. And so there's a chain of events that arise when you have a decrease in prices over time. Like when your money is being more valuable in the future, that discourages you from spending it today. And think about the wider economy. Like if people are discouraged from spending, what happens is that the falling prices mean that you have an incentive to buy the thing in the future and not buy it now. And so the falling demand means that the prices are going to fall further. So why would falling demand make the prices fall further? Well, it's because if your demand is low, the only way that you can stimulate demand is by lowering your prices even more. Remember, we've talked about before that the way a company can entice people to buy its products is by decreasing prices. And so as prices go down, then companies go into default, meaning that they're not earning enough revenue to pay off their debts because they're no longer profitable. And so debt defaults leads to bankruptcies, and if there are more companies that are going bankrupt, then that means the workers aren't receiving a wage. And so if people aren't earning wages, then there's going to be even less demand. So if you got laid off from your job, you're only going to be buying the essentials maybe, and so then this kind of spirals and continues. It's called a deflation cycle or a debt spiral. And it can be really dangerous for an economy when there's an incentive not to buy things. It's bad for employment. And so that's kind of why the Federal Reserve is always looking for between 1% and 3% inflation, is that they know that any less than that, and you're getting pretty close to the risk of deflation, which is even more dangerous than inflation. Okay, so we already looked at this formula for how the inflation-adjusted interest rate can be calculated. And think about if you're trying to earn interest during a period of rising prices, then what that means is that the bank pays a certain interest rate, market interest rate, I sub f, and it's affected by inflation because if inflation is high, people won't send their money to a bank generally if the bank is paying too much less than the inflation rate. So banks have to try and at least increase their rates when inflation goes up. So the market interest rate can be more than the inflation, and if it is, then that means that your purchasing power is increasing, and therefore the real interest rate, I, is positive. But there are some times when the market interest rate is less than inflation, and that means that your purchasing power is actually decreasing. And for that reason, banks would seldom, if ever, quote the real interest rate, I. Instead, banks will only ever tell you I sub f because they don't want people to be too aware of what inflation is doing to their savings because it's less attractive. So to account for inflation when you do an economic analysis, there's a couple of ways of handling it. One is that you can convert all of the cash flows into constant value dollars. So that means convert the amounts to constant value dollars with the inflation rate f, and then use I, the real interest rate, in your calculation of future amounts. Or you can leave the cash flows as inflated dollars and then use the market interest rate I sub f when you're calculating the future amounts. And to get some practice of these two different distinctions, we'll look at that on the back side of the in-class exercise paper I've given you. But I'll mention that in your textbook, Table 14.3 summarizes the ideas that we've been discussing today. And I'll really strongly urge you to review this table after class. This table especially will be kind of a good way to reinforce the things that we've talked about in class today. And they use an example of if you have inflation of 4% and 10% for the market interest rate and a present amount of 1,000 over the course of 7 years, how these different F, P, I sub F, and I, how it all fits together. So just, when you get a chance, review this table after class. Now, what we're going to do in the next part of the in-class exercise is try and do calculations where we're solving for solving for the interest rates that have to be earned when you've got certain goals. Like when you're trying to purchase an item in the future that you know is going to be more expensive than the cost is today. So essentially, how much would you have to save each year to cover the cost of that equipment? And so I'll just remind you that this is the formula to find a given P, and this is on the back side of your paper. So we're going to be using this capital recovery calculation using the interest rate that includes inflation and the real interest rate. So we're going to have this formula where what you're putting in is the I sub F to solve for the fact that the money that you're investing today has to earn a real interest rate and cover the cost of inflation. Okay, so the future worth on the back side of the paper, let's say, what if you are earning an actual market interest rate, I sub F, of 1.25%, but inflation is 3. So that's one of those bad situations where we're saying the inflation rate is greater than I sub F, so your purchasing power is decreasing. So steps A through D, we're going to look at what is the effect of that, where the inflation rate is greater than the market interest rate. Like, what is the real interest rate in a situation like that? So start on part 3, and we'll take a look at the solution for that before we move on to part 4, the capital recovery. So what we are given is a situation where the interest you're earning is actually less than inflation. So that's a bad position to be in, but unfortunately, for a lot of people, that's what's been going on, is that their real interest rate has been negative since the market interest rate that they're earning is less than inflation. So this walks us through the effects of that. If you put $110,000 in the account, you do have more dollars at the end of 8 years. It goes from $110,000 up to $121,000. But the problem then is that prices are going up even faster. So what we do in part B is we're finding the present value of that accumulated amount when we discount it at inflation. So it's as though that $100,000 that you put into the bank, it's only worth $95,000 in today's terms. So that's just an illustration of the fact that the purchasing power is going to decrease. And so real interest rate is the way to know whether you're gaining or losing. The real interest rate tells you whether your purchasing power is declining or increasing. And here, where we're given a market interest rate of 1.25% and an inflation rate of 3%, what we find is that the real interest rate is negative. So that minus sign shouldn't just be discarded. Sometimes we get nervous when we see a minus sign on something like this, but this is a situation where that negative sign tells you that the purchasing power is decreasing over time. And then finally, if you wanted to earn a real interest rate of 1.25% rather than just a market interest rate of 1.25%, so if I is 0.0125, then that means that your bank would have to pay you essentially 4.3% if you wanted an increase in your purchasing power. Any questions on this one? All right, let's look at the last problem then. In the last problem, we're investing $550,000 in a new crane, And what we are trying to find out is how much revenue do we have to earn each year to cover not only inflation, but also to generate a real rate of return of 9%. So, as a reward for undertaking this project, what we want to have happen is we want this $550,000 to achieve an increase in purchasing power of 9% per year. So we want to satisfy the inflation and then on top of it earn a real rate of 9% per year. And so the first thing that we have to do is solve for I sub f, the market interest rate. And then it's that combined interest rate, the one that covers not only inflation but also the real rate of return that we hope to achieve. It's this combined interest rate that we put into the formula where we're solving for A given some P. So this formula is saying A divided by P equals this. So that's the ratio of A to P. So if we're solving for A, we multiply the present value by the result of that ratio. And in each place we're putting in the interest rate that's the combined market interest rate. So what we get is that if we have a revenue increase of $164,000 per year, then we'll be able to cover the cost of inflation and also earn a real rate of return of 9% per year. Okay, that's all I have for you today. I'll leave this up on the screen for a few minutes in case you need to check your work or copy something down. Otherwise, I'll see you on Tuesday, and then the reminder I'll give you is that please refer to that table in your textbook. You really need to review this and reflect back on what we did in the in-class exercise today in order to have the homework assignment, which is due on Thursday. So a week from today for the homework assignment.